Okay, so today we're focusing on applying the Pythagorean formula. Last day you learned how to use the formula and the steps you needed to do in order to calculate one of the legs or the hypotenuse. So today we'll be looking at problem solving, and I've written down a few hints that you can use to get through the questions. Make sure you read over the question carefully a few times to get an idea of what are they asking you to do. I find diagrams extremely helpful. So if you're talking about a boat traveling in water, I would draw a picture of a boat traveling through the water for that distance. Once you've done that, then you can extract the right triangle from the diagram and solve the question. So make sure to show your steps and your thought process and put your answer in a complete sentence. So here we go. Number 1, walking home from school, Joy walked 2 kilometers south and then 3 kilometers west to get home. What is the direct distance from the school to Joy's house? So north, east, south, west. She looks like she started off at school. She walked 2 kilometers south and then 3 kilometers west to get home. So this is where her home would be. And the question is, and 3 kilometers here, what is the direct distance from the school to Joy's house? So what is this distance here? So you can see hopefully the right triangle. And that's what I was saying. You can extract that from your diagram. We have a right triangle. We know that this is 2 kilometers. And this is 3 kilometers. So here was the school, here's her house. What's this direct distance here? So it looks like you're solving for the hypotenuse using the Pythagorean formula. So we go and label the sides. The hypotenuse is always side C, and A and B can be used. The legs can be either A or B. And let's plug in the numbers here. So I'll write out the formula. A squared plus B squared equals C squared. For A, I plug in 2. For B, I plug in 3. So we have 4 plus 9 equals C squared, which equals 13, and we don't want C squared, we want C. So we take the square root of both sides and we end up with C equals 3.6 kilometers. And you can write that in a sentence. The direct distance is 3.6 kilometers. Okay, so example 2, a ship leaves the Pacific coast of BC and travels west for 10 kilometers. Then it turns and travels north. If the boat is 25 kilometers from the starting point, what distance did it travel north? So let's go through this here. So it travels west for 10 kilometers. So here's our boat. It travels west for 10 kilometers. Then it turns and travels north. Okay, and it ends up here. So this is where it ends off. If the boat is 25 kilometers from the starting point, so if this is where it started, this is where it ended. So if this distance here is 25 kilometers, what distance did it travel north? So there's my diagram with my boats, And what I'll do is I'll draw a right triangle with just the key information. So we have 25, we have 10, and we're solving for this side here. So this is an example of where we would use the Pythagorean theorem. We can go and label the sides. So the longest side is always C, and we can call that either A or B. So let's go through this here. A squared plus b squared equals c squared. So I wrote out the formula. Now I plug in the numbers. So we're solving for side A. I can call that x as well, or I'll just leave it as A. For B, I plug in 10, and for C, I plug in 25. So I have a squared plus 100 equals 25 squared, which is 25 times 25. And here, because I'm solving for one of the legs, I have to isolate for this. So I subtract 100 from both sides. And I don't want the square of A, I just want side A. So I take the square root, and A equals 22.9 kilometers. And I can write that in a sentence. So the boat traveled 22.9 kilometers north. Okay, so moving on to example 3. Okay, so with example 3, Alex wants to find out whether the corner of his desk is at a right angle. To figure this out, he measured a length of 20 centimeters along the base of each corner of the desk, and he measured the hypotenuse to be 28 centimeters. So is the corner of his desk a right angle? Okay, so what I'm going to do is I'm going to start off by drawing a picture of the desk and of the measurements. So it looks like they were 20 centimeters length, and it measured a length of 20 centimeters along the base of each corner. So it looks like it's a square desk. And he measured this to be 20 centimeters, this length, and this length here to be 20 centimeters. He then went and measured the hypotenuse, so from one corner to the other, and he measured it to be 28 centimeters. So what he wants to do is he wants to figure out, is the corner of his desk a right angle? So is this here a 90-degree angle? So what we're going to do is let's plug in these values into the Pythagorean formula. So actually I'll draw a schematic first. So we have 20, 20, I'm just drawing the top part here, and 28, and I'll call this A, B, and C. And I'm going to plug in these numbers here to see if they do work inside the Pythagorean formula. So A squared plus B squared equals C squared. So for A, I plug in 20. For B, I plug in 20. And for C, I have a value of 28. So 20 squared is 400 plus 400. 28 squared is 784. So 400 plus 400 is 800, right? So this is not a right angle here, because this value here should have equaled 800. So we can say that no, the corner of the desk is not a right angle? Because c squared should have equaled 800. Okay, last example. So this one here is similar to example 3. It looks like they've done all the calculations for us and they want to see whether or not it is a right angle. So we have a construction company that's digging a rectangular foundation. So they're digging a hole that's a rectangle with a width of 17 meters and a length of 20 meters. To check that a corner is a right angle, so these ones here, to check that they're 90 degrees, the worker measures the diagonal length, so the length from here to here, which is also the hypotenuse, and he measures it to be 26.25 meters. So is this 90 degrees? So we'll do the same thing. We'll plug in the values. I'll draw a right triangle. Well, a potential right triangle. So 20 meters, 17 meters, and 26.25 meters. Okay, and we will label the sides. So A, B, and C, and let's plug in the numbers. So for A, I plug in 20. For B, I plug in 17. And for C, I plug in 26.25. So I have 400 plus 289. And on the right-hand side, 26.25 squared is 689.06. And when I add 400 and 289 together, I get 689. And on the right-hand side, I have 689.06. So we can say that yes, this is a right triangle, even though it's off by just a very slight value here, but we can say that yes, the corner is a right triangle. Okay, and that's it for the lesson. So now you'll be working on problem solving questions in section 1.3.